good to see you all again. I see one or two new names. Welcome. And I'll just simply turn it over to Tony and let him take it from here. Tony, it's all yours, man.
Thank you, sir. So welcome, everybody. Very, very excited and happy to be here with you tonight. And let me just start by saying that this is going to be a very interactive session in the sense of what I really want is if anybody has any questions, if anything, you're looking at anything and you have a question, just go ahead and throw it up into the chat, take yourself off mute, and go ahead and just fire away. This doesn't have to take an entire hour. As a matter of fact, it's probably only going to take about 30 minutes. So there should be plenty of time for questions. And I am very, very, very open about this data. I don't give away the data set per se, but I can tell you exactly how to reproduce it. And the reports I'm going to talk to you about are all available for free on my website. So for instance, this is my website. And I was actually going to start by talking a little bit about an article that I posted today, having learned a little bit about PsiQuantum, actually in our session last week. So I decided to do a little poking around because I'd never heard of them before and look at what their patent portfolio looks like, and that's where this article came from. Very, very briefly, my background is I own my own company. It's a consulting firm called Patinformatics. Patinformatics, our primary product is patent landscape reports. In 2017, I published a patent landscape report on quantum computing. That you can see here, and we're going to jump over to a copy of that here in a few minutes. And actually, what I want to jump over here right now, and then we'll come back to this. And so what you can see here are some headlines, which I'm going to go through in the presentation. But most importantly, there are 4 versions of this report available for free on the website. It doesn't cost you an email address, it doesn't cost anything. You just go there and download it. And so it's important for a moment just to look at what these are. This is the original report. This is about 60 slides long. This is Practical Quantum Computing, a Patent Landscape Report. It's about 62 slides, a lot of detail, primarily focused on devices, okay? Not exclusively, but that was the initial focus. And then just to make it a little bit easier to digest, I have a version of that that's highlights. This is about 20 slides, all right? And it hits all the high points from this one in a little smaller package. Now, I started to recognize as I was getting into it a little bit more that there was a whole field of applications that I didn't cover, cryptography and communications in particular, but also to some degree algorithms and software. And to date, I haven't done anything that I can share publicly as far as sensors, other sort of quantum devices that involve a quantum mechanical mechanism, but not a quantum computer. Okay, and so hopefully at some point I'll be able to make a study like that public. But this is the applications then. This is primarily, like I said, cryptography, communications, algorithms. And then there's a combined report. QIT, quantum information technology, is one phrase that I've heard used to describe the entire quantum universe, as it were, or quantum technologies overall. And so this is the report that we're actually going to look at. Now, this version here hasn't been updated since the middle of 2017. The version I'm going to show you tonight has a few slides that were updated through the end of 2019. This particular piece of work has been written up in Bloomberg, MIT Technology Review, Washington Post, what was the other one? Wall Street Journal, Wired, and CNN. And that's mostly because everybody gets super excited about China and that China is dominating the US in certain aspects of quantum computing. And those are covered here in some of the headlines, and I'll talk about that in the presentation. Anyways, bottom line, these are free. You can go get them. Plus, I can make available the updated version with a little bit of the 2019 data that Terrell and the organizers can share via the Meetup group. So that's no problem. I give this stuff away. Okay. It's done to a client standard, but it wasn't done for a client. It was done as an example of what you could do with patent analytics. And so I'm happy if people just can use it, because I think quantum's a really great idea. It's a really great area. It's a hot upcoming technology. And I'm just glad that I got out in front of it with some initial reporting on it. And that's where how we got to where we are now. So what I'm going to do here is just as an example before I jump into the report. Yeah, like I said last week, really cool. Listening to the presentation, Andre and Denise, and talking about this boatload of money that Quantum received. And so I started to look at it, and I'm also a contributor for Forbes. And when I write for Forbes, they like me to use really sort of punchy and engaging headlines. And so I wrote, quantum computing startup, Quantum raises a ton of cash and is patenting like crazy. And so it's meant to be a little bit funny in that regard. But here's the gist of it. So I talk a little bit about how much money they've raised compared to that to Rigetti. And they've raised more money so far than Rigetti, which is pretty phenomenal. But this is really the gist of the story. And this is an analysis of the quantum computing related patents from each of these companies over the course of the last few years. Now you see here that Quantum, oh, and this is weird. That's funny. Because the version of this that I originally put together, this line was in red. So it stood out a little bit more. But this one here down here, this is Quantum. And you can see 2017, there is nothing. 2018, there's 4. 2019, there's something like 22. And then 2020 is projected, okay? Because of course we're not done with 2020. But so far in 2020, and I talk about this a little bit further down here, that they have 15. So they have 15 innovations published already. And we're not even halfway through the year per se, as far as when these patents. And then you look at that and you compare that to Microsoft that has 21 and Google who has 25. Okay, and so their projections here are a little bit, higher. Google's is ramping up a little bit more than Microsoft's is. Microsoft is projected to be down a little compared to the year before. But the bottom line is that, in this gray line is D-Wave. And so you're talking about big established players. And you've got this sort of a line from a company that didn't exist 5 years ago and wasn't patenting or wasn't having any of their patents published even as far back as 2017. This is remarkable. And then you take, Rigetti as your sort of standard bearer, and you see on average what it is that they're doing. Now they're projected to ramp up a little bit for 2020, but there's a fairly steady line here over the course of the past 3 years. And then you've got this acceleration, which you'd expect, but not nearly to the same slope per se as what you've seen with Quantum. And so,
hey Tony,
yeah,
you might want to remind the audience that the publications is like an 18-month lagging indicator.
It's not though.
Okay.
Because I'm using publication years here as opposed to application years.
Okay.
So I always, that's the reason why I do that. These are just publications. And so who knows what, they would have had to file for these 18 months previously to have them publish here. And so, sometimes people will do that, but I don't like those charts because then everything, slopes down in the last 18 months and everybody thinks nobody's doing anything. But these are the actual, so for instance, Quantum has 39 patent families that have been published. And there's a link in this article that you can go ahead and search for those. So if you just press, you click that link, you'll go to the European Patent Office's Espacenet site, and you will get to see the entire list of Quantum's patent applications. And you can read them for yourself. They look very interesting because they don't look like any other company as far as the things that they're concentrating on. It's waveguides, it's superconducting circuits, it's photonic, quantum photonic communications. It's a lot of different things that just don't look like your traditional quantum computing company. So anyhow, that's the PsiQuantum story. You can, if you go to my website, you'll see that here on the this will load the homepage, and if you just scroll down, there's a list of recent posts, and that one's that one right there. If anybody wants to go and see it afterwards, okay. So, but what we really wanted to talk about tonight was this report, okay. And so again, this is a slightly different version of the QIT report that's on the website, because the first few slides have been updated for 2019. That's because both the Washington Post and the Wall Street Journal asked for updated numbers for when they use these charts in their stories. They didn't want to stop with a projection for 2017. They wanted to know, well, what happened in 2018, what happened in 2019. They asked for those things at the beginning of this year, so I was able to do that for them. So here are those headlines, okay? And it's overall, QIT is amazing. It's utterly remarkable. It's a classic, what they refer to is the hockey stick growth. The idea that you've got a graph that's going along nicely and all of a sudden it slopes up dramatically. They refer to that as sort of the hockey stick. And you've certainly seen that. So computer-related patent family publications increased by 430% between 2014 and 2017. So there's this inflection point that where everything just came together and everybody was patenting and it all started to take off. And you can see that very clearly in the charts. Meanwhile, with the applications, cryptography and communications in particular, those increased 350% in the same time period. IBM is a clear leader in patenting, without a doubt. They're neck and neck with D-Wave for a little while. Now IBM is just blowing it out of the water. And they by far have the most patent families published in the last 2 years. And there's a measure of influence that I'll show you. And theirs is one of the most influential by the factors that I use is what is an influential patent family. The IBM ones are right at the top. But they're not alone. See, here's the thing. This is the thing that I really sort of pressed when I talked about this work in the beginning. At that time, the only people who existed in the world were IBM, D-Wave, and Google was just getting started. And people were also talking a little bit about Microsoft. And so that was any headline, any discussion back in mid-2017. It was all about just them, not even Rigetti. Rigetti was just getting written up in MIT. And so they were just getting a little bit of publicity. But of course, Chad Rigetti is IBM. That's where he got his start. But there were these other companies. Northrop Grumman. Northrop Grumman's got a great portfolio. HP. Now they haven't done anything with it in a while, and I don't know if they're going to come back to it, but they had some really great stuff. Raytheon, Kinetic, Magic. There's lots of very interesting companies that are spread in here. Honeywell was on the list too, and then Intel, and they've emerged over the last couple of years. But then another big thing was that there's a number of Chinese organizations, and this isn't fly-by-night sort of things. These are legit Chinese companies and legit Chinese universities and doing significant work. And so it's been easy in the past, like say 5 years ago, it was pretty easy to dismiss Chinese patents. Most of them were on traditional medicine. They weren't terribly innovative. It was there were lots of them, but they probably weren't worth very much. It's different in quantum. It's real different in quantum. The companies involved, the numbers, when you take a closer look at the translations, what they're covering, this is legit. It's real stuff here. It's something that people really do have to pay attention to.
So these are Chinese patents in the United States or Europe, or where do they publish their patents?
Well, in China, generally. Although some companies, that's a key indicator. When you see that a Chinese patent is also being applied for outside of China, that's one that you especially pay attention to. So yes, but the majority of them at the time, they were just recently published. So they were published at 18 months. Most companies can take up to 30 months to go international. So when this was first done, not enough time had elapsed to be able to check to see if they had followed up with those in other countries or other jurisdictions.
But you have a window into the Chinese patent system for that?
Oh, absolutely.
Yeah.
Yes. The patent databases, even Google, Google Patents has got Chinese patents. Espasnet has got Chinese patents. The Chinese are fairly open with regards to sharing their publications. There's something called the IP5. The IP5 are the world's five biggest patent offices: United States, Europe, China, Japan, and Korea. That's the IP5. And then you throw in WIPO, the World Intellectual Property Organization, as another jurisdiction that publishes a lot of interesting documents. And China is a big part of the IP5 and generally pretty cooperative. So yeah, no, it's not difficult. And the translations are pretty decent. So it's not hard to get a window into the Chinese innovation. And the Japanese are big into this. NTT, which is Nippon Telephone and Telegraph, Hitachi, Toshiba, Fujitsu, and NEC. Huge portfolios. Not so much in the device, although they have some, but really more in the application space. University-backed startups, significant. Harvard, Stanford, Yale, lots of different organizations that you can find their patents in this space, and there's some very, very interesting things there. Then there were some smaller companies, Quantum Circuits, which is the Yale startup, Q-Core, Element 6, which is owned by De Beers because they work in diamond vacancies. Rigetti, of course, 1QB, huge portfolio. 1QB information, 1qubit is huge. And then, Raytheon was one of my all-time favorites in here, very influential. They only have 4 patents, but a lot of people are citing them in the cryptography and communications area. So there's a lot of very, very rich information here. And then these Chinese firms, Kasky, Quantum CTech, Szechuan Quantum, are particularly worth watching and have outstanding portfolios. And then I talk a little bit about the universities involved. And there was the one big takeaway from this, these last 2 sentences here. Quantum computer manufacturers tend to be based in North America, while non-manufacturers, especially the Asian organizations, are focusing more on the applications. And so my contention is the North American organization may control the device or the computer, but Asian organizations will likely end up controlling how those machines are used. And that's an important aspect of the quantum computing environment or the universe, the quantum universe, as far as that's what people have to watch out for. Is okay, you may be able to produce the devices, but there's a ton of organizations, most of them Asian, that are really taking advantage of how they're going to be used in practice. And you really want to try and have a little of both. And I'll show you that with some of the other, when I look at it a little closer at some of the other portfolios. So these next few slides, none of you guys need to see. This is just an introduction for people who don't know anything about quantum computing and a little bit more details about the report itself. But this is where we really want to start diving in. And this is what I meant by overall an increase of 380%. So this is a very big jump, and it all comes right around here. This inflection point here. It was nice and steady. Yeah, there was growth, but then all of a sudden you just it takes off. And when you see stuff like that, that's a clear indicator that they've gotten past some barrier, or there's been a number of new entrants that have gotten into the field, and now all of a sudden you're getting exponential growth with regards to the amount of innovation taking place in a particular area.
So you don't have any, other than just a general sense, have a good sense of what that threshold of what that event was really to kick this off, right? Which is,
No, I've never really thought, yeah, because I got into this in 2017, and I was interested in quantum computers years before, but just briefly, the story of why I did this was, you guys probably know that you've heard the expression, it's the technology of the future and always will be. Feynman did this stuff in the 60s, and there was a ton of talk about it in the 80s, and that we were only a couple of years away from having a device, and it's like fusion. We never quite got there with that. Everybody keeps saying it's 5 to 10 years away, but something changed. And I don't know if it was the beginning of commercial D-Wave devices, or a company like IBM or a couple of those types of companies started to really think that it was possible. So I've never looked for a specific event, and it's never always a single event. But as a collective, people just, big companies and some smaller companies and some university research all sort of came together to create this environment where now all of a sudden it made sense to get back involved. Like you can see, like with Magic, when we look a little more closely at their trend line, they were really super early on quantum key, and then they stopped because nobody was buying it. Early innovator, great technology, can't implement it. But now they've taken off again. When I first looked at their website, there was hardly any mention at all of quantum key. But now if you look at their website, it's just, you can't miss it. So there's a timing aspect too with a lot of these technologies, that sometimes it takes 5 to 7 years for the technologies to actually mature to the point where they can start being used commercially. And so you're starting to see that development of this industry, and it's reflected in the number of patents that are being published.
I mean, it could be, you could work on a few hypotheses and take a look at it and try to figure it out. I think that would be really interesting to get a sense of. So that was publication year, which means they actually applied, you guys said like 18 months prior?
Generally speaking, yes.
Yeah. So be something to, I think Doug's online. He knows history back then, and maybe could kind of get a better sense of that. And the other question I would have then is that where just new entrants are coming in, or did IBM also just start to ramp up at that same time?
I
You know
can
what I mean?
show you
So what the profile looks like.
Yeah.
What's
With
it?
a couple of slides, we'll see company by company comparisons on a year-to-year basis.
Oh, cool.
That
Sweet.
that should help with that. Now, this is one of those slides, like I said, the previous slide was projected for 2017. This slide is the same data, except now it is complete through 2019. And you can see that the trend line is continuing in the same fashion, more or less the same slope as when it was projected in 2017. So it's always nice to, when you do these projections, to come back and check. So what I projected for the end of 2017 was more or less pretty close. In 2018, 2019 have just continued that trend. Okay, so it's the same.
Can I just ask you a question now?
Yeah.
Before I forget it. I mean, I'm kind of, I wouldn't say I'm quite on a mission for this, but I'm quite curious, and I've done a few attempts at trying to get this information. I would love to see what the trajectory of classical computing look like in some form or some metric, so we can do some sort of analysis or comparison of that trajectory that we experienced in classical. What is, is that a hockey stick? Is it some other economic curve line, and try to see how we compare to that history. It'd be a real good, interesting study for somebody to work on, because that might be at least a suggestion, if you will, or suggestive of what our progress might look like, or other innovations like that. So, I'd love to be able to see something like that someday from somebody.
Yeah,
Hey, Carol.
Yeah, go ahead.
I was just going to say that I think you could do something like that for the hardware side of quantum versus the hardware side of like traditional computers. It gets more complicated if you go after the application side because patent laws were very different for applications back in the 60s and 70s.
Well, here's the thing about the device, though. Classic computers are extraordinarily complicated. You'd have to pick one component of a classical computer. Like for instance, I mean, I used to work with a client and they were doing semiconductor packaging. Okay, so semiconductor packaging is just one small portion of the overall, even the semiconductor fab business versus semiconductor circuits versus, the various attributes that go into. I mean, you could come up with maybe if a group of people talked about it and said, okay, well, if we had to pick one aspect of classic computing that we think would be indicative of the growth of the area overall, then I could probably design a query, a patent search to find those. But because of the breadth and the diversity of classical computing, that's the part that makes it challenging. There's literally several dozen, if not more, IPC classes that cover different aspects of classical computers.
Yeah, sure. You got disk drives and all that
Yeah,
stuff.
yeah, exactly. Even the peripherals but even just semiconductor processing
Yeah.
is particularly difficult to try and get your arms around because there's so many things. But it's a great idea, and it's doable as long as we define the scope.
Yeah.
It felt like that scope was going to be a reasonable indicator for the rest of the industry. Those are the caveats.
Yeah, personally for me, I'm on a mission for something like that. I focus on workforce development. So I every once in a while I give it a try, to see what the labor force looks like. And I kind of run across the same problem as what you suggested here with, you've got so many different threads to it. It's almost, it's kind of fruitless perhaps to even try, because, are you looking at engineers, you're looking at software developers or and it all gets lost in history, I think.
Yeah, I mean, it's a multivariate, multivariable problem. And therefore, like for instance, so that is a nice segue. Well, actually not this slide. It'll be another slide. But this is the slide that everybody wants. This is the slide that everybody goes crazy about. And I won't even show you this one. I think the next one is actually the 2019 version. Yeah, this is the 2019 version of that slide. And it's this Chinese business here that everybody goes crazy about. And it is interesting that when you took it to 2019, it did actually begin to taper off some. But I think that's actually kind of gone back upwards. But the fact that you've got basically Japan and the U.S. for some time, and then all of a sudden China jumps in, right around here, just as the things are starting to take off here in the U.S., they're also starting to take off for China. But they're different, as we'll see here in just a second, because this is those same lines now if you break it into qubit versus hardware versus applications. Okay? And the Chinese are driving this line for the applications, not so much this line here. And so this is so when you saw when you saw the aggregate chart and you saw that growth pattern over that extended period of time, that was mostly being driven by the applications. Okay, not that this isn't impressive either. I mean, this is actually, and it's dwarfed. You don't see it. It's not as pronounced because of the size of this line. Okay, that's always what you got to do as far as trying to work out what information you're going to put on each line graph, because you don't want to overshadow or dampen these trends because they're completely overshadowed by these ones. All right, and so, but this is what we do. This is what I do, and other people who work in this area try and do when we dissect these technology areas. It's always important to generate pivots, generate facets, generate categories, call it whatever you want. The real insight is in the examination of these various categories, whether it be US versus China, whether it be qubit versus application, and so on. And that's where you really start to get into what's really going on. So anyhow, that's a little bit about the general statistics. And then this is that same thing now, except only US and China, and just hardware versus applications. So you see here, and the thing so the gray line here, which is this one, and so you notice it's sloping up. This is hardware. This is Chinese hardware. I'm actually going to predict, I'll call my shot now. Eventually, I may wait closer to the end of 2020. But my guess is that the next time I do a full analysis of quantum computing device companies, a Chinese company will have broken into the top 10. That's my prediction. I'm going to call it now. Where right now, none of them are even close. I mean, this number here is nothing. So the direct comparison is this blue one, that's US hardware, versus gray, which is Chinese hardware. And then you've got US applications and then Chinese applications.
We gotta get this stuff. Tomorrow night we have Paul, who's a lobbyist for the quantum industry down in DC and deals with the DC folks. I mean, we got to get these two slides to Paul.
They already have them.
They've got them good.
Well, I don't know about Paul exactly, but I was contacted by the Pentagon and asked these exact questions, and was asked to generate some additional data specific to questions that they had. So I'm pretty certain that some of the highest levels in the U.S. government that are interested in quantum policy, I've been told that they've read these reports.
Well, if you're not doing anything tomorrow night, it'd be cool for you to stop in and
well, that's tomorrow afternoon, isn't it?
Oh, yeah. Good.
Is it tomorrow afternoon?
1:30.
I'll have to check my Quantum-Appalooza site to see what time it is for sure. Yeah. But yeah, I guess it is during the day. Yeah.
Yeah.
So it's tomorrow afternoon for all of us who are not on Denmark time. Terrell's actually teaching a class in Denmark right now.
Yeah. I'm teaching a class on China, by the way, in Denmark, and it starts at 9 a.m. Denmark time, which is 3 a.m. U.S. time. So I'm pretty brain dead by this time of day. Anyway, yeah, it is. I guess it is tomorrow sometime. But yeah, we got to, I mean, it'd be very helpful to get Paul at least aware of this, and, you know, it's nothing better than having information in a lobbyist hands. You know what I mean?
Absolutely. And yeah, well, this group has been so great. I mean, I've really enjoyed the interaction, and Thomas introduced me to all of you, and just very, very thankful to be part of this and be able to share this. And because I think it is. I think it's a great technology. It's an exciting area to look at. And I'm just happy to have been able to put this particular lens towards it. But this, Terrell, this is exactly what you're talking about. So here you go. This is D-Wave and NTT and NEC and Toshiba and IBM and Hitachi and Magic and Microsoft, U.S. government-based research and Japanese government research. And these are all of them with their trend lines stacked on top of each other. And so you can see, for instance, Magic, this line here, had a bunch of stuff, and then they just dropped off completely. And last time I looked, they'd ramped up again. This is one of those situations where they were out in front of the technology curve, and there wasn't a market for what they had developed yet, even though they were a clear leader. And now they've gotten back to it, and they're taking advantage of that. But this is that IBM business. This is incredible. So going back here, 4, 3, 2, 3, 1, 3, 3, 1, 4, 6, 1, 4, 15, 16, 60. These aren't projected numbers. These are real numbers. Okay? Enormous increase. Dwarfing D-Wave, who again also ramped up, but not like them. And even Toshiba. You know, so, 10, averaging about 10. 22, 27. But IBM is, crushing it. It's 60. It's insane. Microsoft, 1, 5, 4, 8, 5, 19, 21. And like I said, so far for halfway through, going back to the PsiQuantum bit, halfway through 2020, 21 already. And that's just going to get higher through the end of the year. Already more than that output there. So lots going on, and you can get a good idea of who's doing the work based on. And this is a project. This is a chart that I designed for most of my projects. It's meant to provide a variety of information to give you context. Lots of people can tell you who are the top 10, but they can't really tell you what the trajectory is, what the trend line is, and in addition to that, what the actual numbers are. So these are called spark lines. Anybody can access them in Excel. And ordinarily, this might have been a heat map, okay? But the thing about heat maps is, the higher the number, the brighter the color. That's generally the way heat maps work. But heat maps I don't like because all the heat gets concentrated up here in the upper right-hand corner, generally speaking. And in this case, you'd probably get some heat down here, but that's an unusual circumstance. But these trend lines are they're based only on the row. So, you're seeing, it's not being clouded by anybody else's number of documents like we see on regular line charts. This is just their line chart for them all by themselves and their trend without any other influence. And so you just basically see in a vacuum what they look like. And so I think it's very useful to be able to see that and then look across to the right and see the actual numbers. So and then I think I've got several of these. We won't spend much time on them, but they are pretty interesting. There's HP, again, big glut or, above average numbers, but then they've kind of tapered off. There's Kasky. That's our first a Chinese company. And they were down a little bit, but then, they had this big one in 2020, excuse me, in 2016 with 20. There's Sichuan Quantum, 55. Huge number. And that's not just smoke and mirrors. That's not just somebody getting paid by the Chinese government to file applications on nothing. That's a big damn deal, all right? So when I say you should be paying attention to Sichuan Quantum, that's why, all right? So there's something there. And then you've got Beijing University, University of S&T of China, Chinese Academy of Sciences. There's my Northrop Grumman. Again, 1, 4, 4, 5, 5, 7, 11, 15. So definitely some interesting things going on there. And the same thing with Quantum C-Tech, another one of the companies I talked about at the very beginning. And then we can break these down by that application versus hardware versus qubit business. And we can start to get an idea of how these companies break out. You see a very distinct pattern with the Japanese. Japanese are application focused, but not exclusively. When we start to see the Chinese ones, you won't see much of anything in the orange and the gray bars. It's all blue. And then you've got D-Wave. Well, D-Wave is pretty interesting because they're not equal, but it's not the case that they're focused on only one thing. They've got fair amount, almost as much in the application space as they do in the qubit space, which is very interesting. And then you see something like IBM, where the application space is lately they've grown this one. So if I was looking at this today, this would be a little bit higher. It might even be more D-Wave like, or even more parity between these. But a lot of hardware and a lot of qubit, and you see this pattern emerge because now here we go. Japanese, now Hitachi's got a little more hardware than the other Japanese. Magic, which is quantum key distribution, QKD. Of course, application based, but still some hardware and other things. Microsoft, a lot like IBM in that regard, more hardware and qubit related than they are application. And again, this moves around. They've got there's a lot of quantum simulation and quantum simulation, chemical stuff in the Microsoft portfolio recently. U.S. government research, Japanese government research. Hewlett Packard, like I said, has a pretty interesting. And there's Kasky, all blue. And Szechuan Quantum, almost all blue. Okay, so because of the way that this has been designed and the various facets that have been built into it, there's a great deal of information without having to read all the patents. And that doesn't, I would never say you shouldn't read the patents, but you can get a great deal of information about windage and elevation just by looking at these sort of metrics and making these meaningful comparisons that are standardized between different companies. Okay, so, and again, I'm a big fan of Northrop Grumman's portfolio, but we'll keep moving down through here. So this is the visualization everybody goes gaga over. This is called a spatial concept map. This is just basically a visualization where these patents are mapped against one another based on the similarity that they have to one another. And the way it sort of works out is down here, this is all the qubit stuff. And then up here, basically, is all the application type stuff. And then over here is a lot of the hardware stuff. And so, and then there's, certain concept areas that I've labeled on here. And now I can put D-Wave on here and I can compare them to IBM and I can compare them to Microsoft and I can compare them to the government, U.S. government research, and I can compare them to Northrop Grumman. And so I like Northrop Grumman because they overlap quite a bit with IBM, but then they've also got, some things here in the quantum dot area, some things in the topological qubit area, even some things that even kind of go into the ion trap area. I like Northrop Grumman because of the dispersion that they have within the qubit generation area. This is a reasonably diverse portfolio that I think is poised to make some interesting advances as the industry continues to develop. But and D-Wave is interesting too, because as we saw in the bar chart, they've got a fair amount that's bleeding up into this application space. It's not all down here or all over here in the hardware. They were early on getting the idea that they were going to need the software to go along with the hardware, and we're starting to make investments in patenting some of that, some of the innovations in those areas. So this is a spatial concept map. This is what the Chinese look like. All right. So quite a bit of hardware. Kasky here, you can see that they're this would be something that like, for instance, if I was PsiQuantum, this is something I might want to take a closer look at, because their approach is a quantum photonic communication based. It's photons as the qubit and means of working with the photons across the semiconductor wafers. And that seems somewhat similar to what we have here in these areas. Might actually be interesting to redo this map with them on it to see exactly where they play out these days, which is something I'll probably do in a future study. But this would be where your magic is. This is your QKD type stuff and various other aspects. And you see that they're big up in there too, the quantum cryptography type stuff. So it's very easy to make these comparisons because the underlying map never changes. What's underneath here that's all that changes is what you highlight and what you color. And so it's a fantastic way of making comparisons and to take a little closer look. It's sexier than a column chart. Not that you couldn't do this with a column chart, because you could, we did. But this is the visual that everybody always goes ooh and ah about. This is the one that really pops for them. And then this is the Japanese. And this should be a little bit concerning, I think, because nobody talks about the Japanese. And yet they're all over this map. I mean, all over it. You'd be hard pressed to find a portion of this that doesn't have a Chinese influence. And this is only the top 5 companies for Japan. And they're all over the place. And again, nobody ever talks about them. But they're clearly a significant player. They're just not racing to get the headlines. But they're definitely all over it. And then this is a different type of analysis. This is a forward citation network diagram what this is designed to do is looking at which companies are being cited by other companies. And so it's a measure of influence in my world that larger bubbles means that there's more links. And so you've got IBM that's fairly influential, but not quite as influential as Raytheon. And you've got D-Wave, you've got Kinetic, and British Telecommunications is actually surprisingly influential in this area. And there's NEC, and there's HP, and there's Toshiba. And so if you study this map for a while, you get some ideas about some influential portfolios. Northrop Grumman's on here as well. And this is what's led me to believe on those headlines that I think the Raytheon portfolio, my two favorites that aren't the big players or aren't a small startup are Northrop Grumman and Raytheon. I think they have very, very good portfolios. And Honeywell also shows up in here. In 2017, they didn't have, just like Intel. Intel and Honeywell would now be in the top 10 in both of these analyses. But there's a lot to be said for, and I know Northrop has an active program. I know that they're working with Element 6, which is a De Beers company for using diamond vacancies to help support their areas of research. But and then this is just a call out. This just is highlighting IBM in all the different companies that they've influenced. So either they cited them or they're being cited. These are all the companies that they interact with. And then, in a similar way, if you look at Magic, which is, again, the clear leader in QKD starting out, they had a huge impact on an enormous number of companies in the development of quantum encryption. And you can see that here based on their citation network. And that's it. That's it for the slides. On here, there's a little bit about how I built the collection and how I cleaned it up and things of that nature. And then there's some acknowledgments. I get my data from this company, Clarivate Analytics. They have these things called Derwent abstracts that are very good for finding information. And the spatial concept map was built with a piece of software called KMX Patent Analytics. But the majority of the charts and graphs are actually from good old Excel. I have data tables with lots of columns and pivot tables. Then I just copy and paste material out of the pivot tables and put them into a new sheet. And then I just use Excel to draw a lot of the line graphs and the column charts and stack bars and all those sorts of things. So with that, we've got time for questions. I went a little longer, but we had a little bit of interactive discussion throughout. So like I said, happy to answer questions.
I have a question.
Oh, go ahead.
I was just wondering, how come the U.S. aren't doing much research in error correction? Is it because we're going towards maybe fault tolerance? Or I was just wondering why U.S. has nothing in error correction, but but Japan and China does.
Well, you can't say that overall because the only thing on this, because I'm assuming you're talking about this one, okay? And this is only these 5 U.S. companies. So these 5 U.S. organizations, including the U.S. government-based research, aren't working there. But if I had everybody, if I had all the U.S. companies, because I could color this by, just like I had the line chart up here that looked at, I guess this one's probably the best one. No, not that one. Yeah, no, maybe it's this one. There you go. This is U.S., China, Japan. I could do a version of the spatial concept map that showed U.S. priority countries versus Japanese priority countries versus Chinese priority countries. That wouldn't be hard to do. And I'm sure under those circumstances, you would see quite a bit more of the U.S. color up in a lot of these other areas. It's just not these companies that are doing that in this particular case.
I have another question about the market segments. If I understand this, right now what you're covering is quantum computing and quantum communications, but not quantum sensing. Is that correct?
Yes, generally speaking, that is correct. I have done a separate study on quantum sensing. It was done for a private party. And so I'm aware of it, and I know generally the answers, but I haven't been able to share them publicly. But yes, there's some overlap, but not a lot.
Okay. The thing I think would be a very interesting analysis would be U.S. versus China based on whether it's quantum communication and quantum communication or quantum computing. Because I think what you'll see is the U.S. is stronger on the computing side and China is much stronger on the communication side.
We see that already based on without sensing. That's what you see here with a lot going on in these areas. But you're absolutely right. I can tell you that because it's not giving anything away, that when you're talking about devices as opposed to applications and software and things of that nature, Chinese sensing devices, they're just as big, if not bigger than the U.S. So yes, in that area, that there's even more concern. I can say that without doubt of being contradicted.
Okay. Yeah, as I said, it would be interesting just to graph by segment the numbers of different patents that are from each country versus the market segment.
Yeah, and what's missing right now is sensing from this particular study, but it's very doable.
Okay, very good. Thanks.
Certainly.
Anybody else? This has been a pretty quiet night. Must be something in the water.
I got a question.
All right, Jamie, cool.
So 3 names I didn't hear tonight so far are Alibaba, Tencent, and Huawei. I was wondering if you've run across any patents from those 3 companies.
Good catch.
Yeah, and that's what I mean. This was, from a company perspective, the data hasn't been updated since the middle of 2017. Okay? Now, there's a couple of charts in here that are through 2019, but they were only done at the aggregate level because, the Washington Post and the Wall Street Journal weren't paying me to regenerate the amount of detail that went into the original report. At some point this year, I will likely go back and do it. Now, I did the company study alone for Microsoft, Google, so on. But that's what I mean. I can nearly guarantee that one of those 3 companies will be in the top 10 when I go to redo this and include 2019 and 2020 data. So I'm pretty confident that is what is going to happen. I just haven't had the opportunity to go and do it yet because quantum's not, there was no client for the quantum report. It was just done as a case study. As a means to demonstrate to people what could be done. So at some point, I feel like I got to go back and update it and share some of the new insights. I just haven't done it yet.
Should I get everybody to vote on whether you should do that or not? Should I get a poll out there quickly?
Daryl, before you ask
minute?
for a vote, why don't we ask Tony how many hours he spent doing the previous one? So how long did it take you to do the previous report, Tony?
Well, I had a couple people helping me, but all told, it's at least 150 hours of work to generate the first collection, with both application and device. The quantum sensing report that I did was a little bit less. It was about 80 or 90, but that was because I already knew a fair amount about what to do, and I just had to do a little bit more research to understand the difference, understand what quantum radar looks like versus quantum imaging versus a variety of different aspects that were more the accelerometers, the atomic clocks. So there's a variety of quantum-based devices, quantum mechanical devices that make up the quantum sensing. And so I educate myself a little bit on that. But yeah, I mean, that's the thing. I mean, I will go back and do it. It'd be better if I could actually justify it from a, because it's opportunity cost. I mean, I have other clients. Mm-hmm. I work for a couple of Fortune 50 companies, for instance, and they keep me pretty busy. Not that I'm not interested in other clients, but, and plus, Denise isn't on here right now. But, I've been talking to her and Andre a little bit about One Quantum and whether there are opportunities there. And of course, IBM's got deep pockets. They could always toss me a bone, and they're going to look great. So
yeah, really.
So they could, they might be able to afford to pony up a little bit for the good of the order.
I'll
anyway.
I'll check in with Beijing, see if you can get some cashish from them.
Yeah, well, I'm not sure. Like, I'm not entirely positive how excited PsiQuantum is going to be, because I tagged them in my LinkedIn post and in my Twitter post, so they have to know that post is out there. I can't imagine they're terribly excited about somebody putting their list of patents up for everybody to see.
Oh, if it's positive news for them, they're more than happy to have it. Trust me.
Okay, well, that's good. I'm happy.
That's the story they want to tell. The question I would have, not to go off on a tangent, is really the quality. That's another story. Never mind.
Yeah.
Hi, Tony. It's David Garvin here. Can I ask a question, please? Can you just spend a minute or two talking about the methodology that you use in terms of how do you classify a patent into either application or hardware, or like the different categories?
So there's a variety of ways of doing that. It's a little bit straightforward between application and hardware, in the sense that there are specific patent classification codes that talk about quantum cryptography and about quantum communications. They're explicit. And as far as quantum software is concerned, I have an entire list of words and a mechanism by which I can identify when we're really talking about a quantum software document. And the same thing with sensing. I had long strings of keywords and codes and combinations of keywords and codes that I used to be able to isolate whether something was an accelerometer, whether something was doing a magnetic measurement, whether it was an atomic clock, and so on. And so as you build these collections, sorry about the clock in the background, you kind of build them piecewise usually. If you can identify what your categories are going to be, and then you build your queries around the categories and then combine them together at the end, then you have your categories already laid out so that when you go to do the analyses, it's fairly straightforward. And there's actually a classification code for quantum computing, Q06N10. And it's actually a fairly decent code for catching most of the hardware-related quantum items. So that's how it's done.
Okay, great. Thank you.
Anyone else?
Hi, Tony. John Zer here with a question for you. I'm wondering if you might know of a comparable time period in the classical computing world in terms of volume of patents and then the slope of the curve for the explosion period there from 2014 to 2017.
Yeah, I could only speculate. We talked a little bit about that at the beginning, and Terrell was interested in a similar study, and I'm sure it could be done, but what I'd want to suggest is you find like semiconductor packaging is a concrete, it's a specific aspect. So generating a trend line on a specific aspect of classical computing like semiconductor packaging would be fairly straightforward. And even lithography or a handful of other technologies that are essential to semiconductor fabs, you could do that. It's a little harder when you're talking about just the development of semiconductor wafers or transistors and various other aspects as well, because they're over time they've gotten much more complicated, and there's many more subcategories. So I'm sure it could be done, and of course I think you'd see, but then it's all relative also, because then you have to take into account that there weren't as many things being patented, and this was mentioned earlier, I think by Thomas, back in the 60s. And so you'd have to standardize everything against the patenting output for the entire country, for instance, during that given time period. So that even though you saw a big spike, well, how much of that spike is related more generally to the idea that more patents were being filed in that particular year. So it can all be done. Once again, it's with anything like this, it's always why does somebody want it, and are they interested enough to help fund a study? If I was working exclusively at a university, some of these would be really cool things to do, and look to publish on them. But unfortunately, that's not the situation I find myself in. As fascinating as it would be, that's just not what I have the bandwidth to be able to do.
There's a lot of low-hanging fruit in this industry right now, and just mapping that to just a basic S-curve, is paper worthy, frankly.
I was a little surprised. I'm actually a little bit shocked at the attention that the report has gotten. And they're like, even Thomas, Thomas contacted me to be involved with this because he saw the report. I didn't reach out to him. I didn't say anything to anybody about it. And the same thing with Wired and CNN and, all these folks, it's out there. Google search on it. It's a fairly high listed on the search page. And so, it's just been word of mouth.
Yeah, I actually found the report through one of the news articles that mentioned it, and then I followed that to your website, and that's when I saw the link of the report, and I reached out to you.
Cool. Good detective work, Tom. Thank you. And here he is. And he'll come back every year.
Well, like I said, I think this group is great, and you guys are connected in lots of really great ways, and so I'm excited to meet all of you and be a part of this group.
Anthony, and just to ask another question, which you touched on towards the start of your presentation, but in terms of, because I'm not from a patenting background, so I'm not totally clear on the terminology, but here you're saying these are patents that have been granted already, is that correct? And that's compared to 18 months before that is on average when they file the application. Is that what I'm understanding?
No, no, not exactly. And it's a little complicated, and Thomas knows this as well. But just to start with the first part, this is a mix of granted patents and pending applications that is covered in these reports. And the unit of measure, what I'm actually counting is something called a patent family. All right, and so the basic idea there is if somebody files in the US, in Japan, in Europe, and in China, and in Korea, you only count it once as opposed to counting it 5 times if you were looking at all the publications. And in the same fashion, if it publishes as a pre-grant application and then publishes again as a granted patent, you don't count it twice because it's the same inventive output. And so there's a real art to actually doing the reductions from a worldwide search of all of these documents and getting it to what is really the inventive output. And so a fair amount of effort goes into that. So that's part one. Part two, the 18-month business is the way that works generally is that if you file a patent application, and it's not a provisional application, we got into that in Tom's session as well, But if it's an actual application that you've said, yes, I want this examined. Okay, I want to submit it. This is my official application, and I want to have an examiner start looking at it. 18 months from that point, it will publish as what we refer to as a pre-grant application or a pre-grant publication. And then it may take another 2 to 3 years before it grants anywhere. Okay, and so there are lots of nuances, and even calculating those years, I tend to use what I refer to as the earliest publication year now instead of the latest publication year. So if something grants last year, I don't count it as having granted this last year. I count when the very first family member published, which may have been 2 or 3 years earlier. So it gets totaled up with that year's worth as opposed to the most recent family member. So again, probably maybe more detailed than you were looking for. Apologies, but that's why to some degree patent analytics is not for the faint of heart. It takes a fair amount of work and experience to kind of sort out all these nuances.
Yep, that's thank you. That was the kind of detail I was looking for. But so I'm still worried about one thing, which is that somewhere in the process, does it filter out frivolous, for want of a better of a word, patents or applications? I mean, so what's to stop me tomorrow from just filing something which could be complete rubbish? Does that get captured into your numbers or not?
Well, the short answer is yes, of course. Here's a little rule of thumb that I have. I try to make my collections such that they have about 90% recall and at least 70% precision. Now, somebody will look at that and say, wait a second, you mean 30% of the material in there is rubbish? Yes. And there's a couple of ways to think about that. First off, the likelihood that the rubbish is actually going to generate a signal is fairly small, okay, because the rubbish doesn't aggregate. The good stuff, there's usually more good stuff. It builds on itself and you get a signal. And that's what we're looking at here. We're not looking at specific patents. We're looking at signals over a large collection. So statistics start to play a part in all of this. So there's one thing. And second off, it's not free. Patents cost money, all right?
Yeah, that's true. Yeah.
They cost a lot of money. And there may be some rubbish out there, but I guarantee you at 10 to 20,000 or more per crack, ain't a lot of rubbish. Somebody had to care enough to spend that kind of money to get this thing filed, all right? And so I don't even look, patents are a great indicator of scientific advancement and knowledge. As a matter of fact, they're almost exclusively good that way. But more importantly, as far as I'm concerned, they're a determination of economic interest because you don't file patents for nothing. Even IBM, they file a ton. But I guarantee you they're looking at every penny, and they've got big teams that decide what gets filed on and what doesn't. And a lot doesn't, as much as is what does. So it's always an economic decision as to when you're going to go ahead and spend that money. And so I think that cuts out a reasonable amount. But we hear about that all the time. The whole business with the patent trolls and the whole narrative that Google wants to sell everybody about how all these patents are crap. It's not, A, it's not really not true in quantum computing, but B, it's not really true overall. Somebody spent that money. They probably had a reasonable reason, even if the market changed, and all of a sudden it's not worth anything anymore. But nobody files a patent just because they think it'd be a fun thing to do.
Not unless they also are the type of people who burn money in their fireplace.
Yeah, and that's about what it amounts to.
Mm-hmm.
Lighting up the $100 bill to light your cigar. It's just crazy.
That's a good point for us novices, if I can say, because that's probably some perception that we all have that, okay, for $500 or something, but it's a little more than that.
Yeah.
So thanks for setting us straight on that. Anybody else before we call it a night here? Okay. Well, thank you, Tony, and thank you, Tom, for finding Tony, and for Tony for doing this. We appreciate it. And the invitation's open anytime you want to come out and talk about your work. We're more than happy to listen to it and benefit from your 120 plus hours or whatever it is. So thank you on behalf of everybody here, and for the people that we'll try to get your word out on get the word out on the work that you have done. The more eyes on it, the more value it has. And I think it's probably a good secret right now, but maybe we can get Doug to maybe get some article put together in concert with you perhaps, and get it out on the quantum computing reports perhaps in some way.
Actually, I did have an article last year on patents, but I think it came from somebody else.
Ah.
Yeah, well, if you wouldn't mind
Okay.
posting that link, or you know, I'd be curious to see it. I'm always kind of
Okay.
keeping my eye open for other reports, and if you have an opportunity to look at this one and see you know, how they compare, I'm always interested in the feedback.
Yeah.
Okay, I will do that.
Yeah. That'd be cool. Excellent. Okay. Well, good night, folks. We'll
Okay.
see you maybe tomorrow afternoonish or whenever the next event is by the Philadelphia Harrisburg meetup, or Washington meetup, or Toronto, or wherever. We'll see you out there. Thanks a lot for coming by.
And we've got one other thing. If you have any
Yeah.
suggestions for other speakers, let us know. We're always willing to take other speakers.
Absolutely. It's all about getting discussion and awareness and all that kind of good stuff. So you don't have to be a PhD to give a talk at Philadelphia Harrisburg. So cool. All right. Thank you, Tom. We'll see you all next time. Thanks again, Tony. Appreciate it. Good night.
Good night, everybody. Thanks so much.
Night.